quick review of what we learned in the last classes. So we learned about vector differentiation, how derivative of a vector with respect to vector function with respect to its scalar variable, it has a geometric representation. If the scalar variable is a parameter representing the point in space, then this derivative will be a tangent to the curve chalked out by the vector function. The vector function is like if the vector function represents the position vector of a point, then its derivative represents the tangent of the path chalked out. Then this position vector, if it is of constant magnitude but its direction keeps changing, then this is a case of the point moving around the circle. Now in that case, the tangent dr by dt will be perpendicular to the original radial vector. So the vector r bar will be the radius vector. So r dot dr by dt will be 0. However, on the other hand, if the direction is constant but the magnitude changes, so the direction always remains the same, magnitude changes, so dr by dt exists but it is parallel to r. Dr by dt will be parallel to r. In that case, the vector, the cross product with the original vector of the derivative is 0. Then we discuss the general rules of differentiation. The UV rule applied on scalar and a vector product, scalar function and vector function product. UV rule, the UV rule applied on the dot product of two vectors, UV rule applied on the cross product of two vectors, then the UV rule applied on the box product or the scalar triple product of vectors and the vector triple product of vectors. So this we discussed. Then we talked about the scalar and vector point functions. So, or what we call as scalar fields and vector fields. So we discussed what is a scalar field. It is a set of all the values of the scalar point function in a domain. So here the domain is in this figure, the domain is all the coordinates belonging to this room, and the vector function, the scalar function, is that of the temperature. So, and then vector point function, for example, velocity vector field for fluid particles, all right, across a body, a volume, how the particles vary. This is vector field. Now we introduce the concept of the del operator. The del operator or nabla operator is I dou by dou x plus j dou by dou y plus k dou by dou z. So when this nabla operator or the del operator is applied on the scalar functions or the scalar field, then it is called as the gradient of the scalar field. So del f is also called as grad f or the gradient f is I dou f by dou x plus j dou f by dou y plus k dou f by dou z. So the del operator operates on f. So it represents a gradient. Now, very important notation, very important geometrical representation. If the scalar point function represents equipotential surface or isothermal surface, it represents some surface. Okay, f of x comma y comma z is equal to c. We call it as a level surface. And what does grad f represent? Grad f represents the perpendicular or normal to the surface. Okay, it represents normal to the surface. Dr is tangent, and grad f will be perpendicular. So grad f is normal to the surface. This is a very important concept which will be used, and problems come in GATE on this. Next, directional derivative. Now, directional derivative is the rate of change of scalar point function in the direction of a vector A. So, grad f, if we want a directional derivative along a certain vector, so it is grad f dot a cap. So directional derivative is the gradient vector along a certain direction, grad f dot a cap. So then properties of gradient we know operates on sum of two functions, then product of two functions, and quotient of two functions. The usual. Now, very important definition of a conservative vector field. Conservative vector fields are those vector fields which can be written as a gradient or the gradient of a scalar point function, of another scalar point function. That is, those are called as the conservative vector fields. So these were the concepts of gradient, directional derivative, then the properties of gradient, and then conservative vector field. We did some problems on it, and then we went to divergence of a vector field. Earlier it was del operator operating on a scalar point function, now on vector point functions. The first one was divergence. Now, del dot f is a scalar. Okay, del dot f, because del is a vector, derivative operator vector. So del dot f will give us a scalar quantity. Now it operates on, so just like dot product, so dou by dou x operates on f, the x component of f. So dou f by dou f x by dou x plus dou f y by dou y plus dou f z by dou z. So this is the divergence. Now divergence, as we represented in the last class, it talks about the difference of the outflow vectors versus the inflow vectors in a small area around the point, or the small volume around the point. This is called as divergence. So if in fluids, it represents, like what is the potential of that in that particular, around that particular point. Is there a source? That means the outflow is greater than the inflow, then it is a source. If it's a source, then the divergence is positive. Then if inflow is greater than the outflow, if the inflow is greater than the outflow, then the divergence will be negative. Divergence will be negative. Now, and if the inflow is equal to the outflow, then it is divergence will be zero. So this is not just applicable to fluid fields, but for any vector field. So when it talks about fluid flow, then it is like we call it as a incompressible. Del dot V is equal to 0 represents incompressible fluid flow. Okay, divergence is 0. Whereas when we apply that divergence to electric flux, then it is called as the solenoidal vector function. Then this particular, if del dot V equal to 0, then we say V is solenoidal. All right. So this was what we discussed about divergence. Then we discussed about curl. Curl of a vector field is del cross F. We can find out this using, the determinant ijk, dou by dou x, dou by dou y, dou by dou z, x, y, and z components of F. This is what we get. Now, physical interpretation is that if at a point, if you put an object in the vector field, now does that have a rotational effect on that object? If rotational effect is present, it is a curl is non-zero curl. Okay. So last time we discussed about a fluid flow, and we put one matchstick, and the matchstick tends to rotate. That means the flow field has a rotational effect. And next, so del cross V is in this particular case, we have shown that it has a rotational effect, and the vector will be perpendicular to the plane of rotation. So again, one misconception we avoided, I pointed out, curl doesn't mean that the vectors are curling. It may curl. That means it can be a circular flow, like the sink flow. Sink flow is considered as an irrotational flow, very amazingly, till it comes close. Sink flow in the sink. So it is not necessary. It is just that if you put a point there or an object like this, which has does it rotate? If it rotates, the curl exists. All right. So if it rotates anti-clockwise here, if this is the x-axis and this is the y-axis, if it rotates anti-clockwise, yeah, then that means the vector is pointing towards positive z direction, the curl. If it rotates clockwise by the right hand thumb rule, the curl is pointing inwards to the plane of xy. So a vector field whose curl is 0 is called as the irrotational vector field. Now we use this to find to use one concept. This is important concept, that in a rigid body rotation, in a rigid body rotation, if the angular velocity vector is given, then tangential velocity is omega cross r, where r is the position vector of the point from the origin, the axis about which the solid body is rotating. Now, del cross V is equal to twice of omega. This is an important result. Del cross V is equal to twice of omega. And then their properties of vector cross, curl of the vector function. Just a second. Okay, so this is the cross product. So, the curl of A plus B is curl of A plus curl of B. Curl of scalar constant times a vector is k times the curl of vector A. And if it's a scalar point function, very important, this formula is very important formula. If it's a scalar point function, then just if it's a scalar point function, then it is grad f cross A plus f into curl of A. And then the last one, very important, conservative vector field. We discussed that conservative vector field is that field in which we can write this as gradient of a potential, scalar potential. So like this, V can be written as grad f. Now the del cross gradient of f will be 0 always. So for a conservative vector field, if V is a conservative vector field, another definition of conservative vector field is its curl will be 0. Its curl will be 0 always. All right. So now I will share you the screen for class time. We will do problems on class time. I'm starting a new session. You please open your class time. Go to classtime.com. Okay. And like this, go to classtime.com, JNJ4D3. JNJ4D3. So go to classtime.com and we will get here. So go to student section, JNJ4D3. and join. Put your name. Or join with Google. One of them. Okay. So now I activate the first question. I'll give you time till all of you join. 4 of you have joined so far. Okay, 6 of you. One more person to join. Okay, code. Code is this one. JNJ4D3. If you are able to see. JNJ4D3. Okay, the first question you start attempting. I'll start the timer. First question. It's a directional derivative problem. Please attempt. No answers so far? Please attempt. Okay, I'll solve. So look at the solution. So look at the solution here. So f is unknown to us. So let f of x comma y be some u I cap plus v j cap. All right. Now u and v are functions of x and y. So now what is given is, now let us say this vector is a bar I plus j. So a cap will be I plus j by modulus of I plus j is under root 2. Root of the squares of the coefficients. One under root of 1 square plus 1 square. Similarly, this one b is minus 2j. Okay, the direction of b is minus j. The modulus is 2, so minus j will be the direction of b. Now what is given? Given that grad f dot a cap is 2 root 2 at, you know, at 1 comma 2. And so derivative of f of x comma y at 1 comma 2 in the direction of I plus j is this, and in the direction of minus 2j is minus 3. Is minus 3. So grad of f dot b cap is minus 3 at 1 comma 2. That means x and y 1 comma 2. So now let's work on it. So grad f is dou u by dou f. Grad f is dou u by dou x I'm sorry, f is a scalar point function. Remember, f is a scalar point function, so let us say it is just f of x comma y. It is a function of x comma y. We don't know what that function is a scalar point function. I wrote it as a vector. No, it's a scalar point function. So this is grad f is dou f by dou x I plus dou f by dou y j. Okay. Now f is a function of x and y. Now after this, you dot it with a cap. So grad f dot a cap is dou f by dou x times 1 upon root 2 plus dou f by dou y times 1 upon root 2 at 1 comma 2 is equal to 2 root 2. So from here, what do we do? Multiply throughout by root 2. So you get grad f, dou f by dou x at 1 comma 2 plus dou f by dou y at 1 comma 2 is equal to 2. All right. So this is equation 1. Next is dou f grad f dot b cap is -3. So let us find that out. So grad f dot b cap will be what is b cap? Grad f is this. Ignoring the k component. Minus j. B cap is minus j. So this is minus of dou f by dou y at what? 1 comma 2. At 1 comma 2, this is equal to at 1 comma 2. This is equal to -3. This is the given condition. So we get dou f by dou y at 1 comma 2 is equal to +3. All right. So from the first equation, at 1 comma 2, dou f by dou y is +3. So dou f by dou x should be -1. So from 1, dou f by dou x at 1 comma 2 is equal to 2 minus of dou f by dou y at 1 comma 2. So this is 2 minus 3, which is -1. So we got two things. Dou f by dou y we got, and dou f by dou x we got. So we have solved it. So therefore the gradient, therefore grad f at 1 comma 2 is -1 times I cap plus 3 times j cap. Now the question asked is, now the derivative of the directional derivative of f in the direction of -I minus 2j. Therefore, direction derivative in the direction of -I minus 2j is, let's say this is C. C bar is minus I minus 2j. So C cap will be minus I minus 2j upon under root of 1 square plus 2 square under root 5. So grad f dot C cap is being asked. So that is minus I plus 3j dot minus I minus 2j upon under root 5. This will be 1 upon root 5 times minus 1 into minus 1 is 1 plus 3 into minus 2 is minus 6. So we get minus 5 upon root 5, which is minus root 5. Let's look at the answers. All right, let's see. 2f by dou y is minus 3. Dou f by dou y is just a second. Okay, there may be a typo. The correct answer given is minus 7 upon root 5 in the main question. No, just a second. Let me see. Minus 7 upon root 5 is the correct. So I think then this should be plus 3. Maybe a typo in the question. If this is plus 3 given, then this will be minus, then answer comes out to be correct. Then this is minus. No, then the whole thing goes. There's something.
Sir, first equation.
First equation is
Right.
no, actually this is right. There is some, I'll just check 1 second. The answers, given answers. This is minus 3, so this is plus 3. This is the first equation.
It is 4, I think.
Oh, correct. You're right. Thank you. If this is 4 and this is plus 3, then this has to be plus 1. Thank you. Plus 1. This is plus 1. So the directional derivatives are this, right? So now you get minus 1, minus 6. So minus 7 upon root 5. This is the correct answer. Yeah. So this is the correct answer. Minus 7 upon root 5. So this question was that we find directly the gradient, the function is not given. So we find the partial derivatives with respect to x and with respect to y from the given conditions. Its directional derivative across two vectors is given at a particular point. So we find that. Now at the same point, we have to find the directional derivative along another vector. So once we find that, then we do a dot product, we get this. Okay, next we will do the next question. Others who have not joined, please join class time. This is the code JNJ4D3. Open class time and join. JNJ4D3. JNJ4D3. Capital J, capital N, capital J, 4, capital D, 3. So let's do the next question. So find the directional derivative of this function in the direction of 4i plus 3j. This is easy. This you should be able to solve in a minute. Second question. Why very few students for this problem? This is a very, very simple question. Okay, just look at the solution now. So the directional derivative is grad f dot a cap. So first grad f is I cap times dou f by dou x plus j caps times dou f by dou y. So it is I times partial derivative of x square plus y square with respect to x is 2x plus j cap times partial derivative with respect to y is 2y. Now, next, what is a cap? A is 4i plus 3j upon a cap under root of 4 square plus 3 square. So it is 4 by 5i plus 3 by 5j. Now, grad f dot a cap will give us 2x. So dot product of these two vectors. So 2x times 4 by 5, it will be 8x by 5 plus 2y times 3 by 5, it will be 6y by 5. Now at 1 comma 2, this is 8 upon 5 plus 12 upon 5, 6 into 2. So 20 upon 5, we get 4. So answer is 4. Okay, answer is 4. It is simple. Directional derivative is grad f dot a. So these are past gate questions directly. So answer is 4. So let's move to the next question. I have to enable the question 3. Yeah. This is a question. For a scalar field given like this, magnitude of the gradient at the point 1 comma 3. Find the magnitude of the gradient at the point 1 comma 3. This is again a simple question. Good, good. What? Others? Please answer. Another minute. I have a lot of questions to answer, so I think you should do fast. Four more. Okay, look at the solution again. If you understand the concept, it is very, very easy. So u is the function. So I have to find grad u. So u is a scalar. It's not a vector function. It's a scalar function. So I get I dou u by dou x plus j dou u by dou y. So I get I times dou u by dou x is 2x upon 2. So I get x plus j dou u by dou y is 2y upon 3. Now the gradient at 1 comma 3, when we substitute, I get I plus 2 into 3 upon 3, I'll get 2j. What is the question? Magnitude of this gradient. So magnitude of this vector is under root of 1 square plus 2 square, which is under root 5. Simple, very simple. There was no difficulty in this question, provided you understand the gradient. Remember, gradient is I dou by dou x. It's an operator, differential operator, plus j dou by dou y. This gradient. So this is root 5. All right, so we move on to the next question. So check the next question. So I'll give you 3 minutes time for this question. scalar field is given by x to the power 2 by 3 plus y to the power 2 by 3. The derivative of f along the line y equal to x directed away from the origin at the point 8 comma 8 is. So it's asking for the directional derivative. And we have 2.5 minutes from now. Two answers so far. Others, please do. All right, only two answers so far. Okay, this is not a difficult question. Just look at this again. So similar to the previous one, just that we have to find along the line y equal to x. Along the line y equal to x, the vector will be I plus j. That will be the vector, because 1 comma 1, 2 comma 2, 3 comma 3 are points on the line y equal to x. So position vector of say 1 comma 1 is I plus j. So this is what it is. A cap is I plus j upon root 2. Now del f is I dou f by dou x plus j dou f by dou y. This is I times 2 by 3 partial derivative of f. F is this. x to the power 2 by 3 plus y to the power 2 by 3. So 2 by 3 x to the power 2 by 3 minus 1, that is minus 1 by 3, plus j cap times 2 by 3 times y to the power minus 1 by 3. Now del grad f dot a cap, this is what we want. The derivative of f along the line y equal to x directed away from the origin. So we want this grad f dot a cap. So this is grad f, this is a cap. So product, you get the dot product 2 by 3 root 2 times x to the power minus 1 by 3 plus 2 by 3 root 2 y to the power minus 1 by 3. Okay. Now x to the power minus 1 by 3. Now at 8 comma 8, at 8 comma 8, you will get 2 by 3 root 2 and 1 by under root of 8 or cube root of 8. 2 cube is 8. So cube root of 8 is 2. So we get 1 cancels. This is 1 by 3 root 2 plus 1 by 3 root 2. So you'll get 2 by 3 root 2, which is root 2 upon 3. Root 2 upon 3 is the correct option. Clear? Very simple. Just applying the concept. You get definite questions from vector calculus, and they're all simple. It's just direct application of formula. We just need to do it right. So that's why I'm making you practice. This is you will have to practice this one. It will not come just like that. You have to remember things. So next question. Question 5. I have released question 5. You can check it. I'll give you 3 minutes from now. Please start. Okay. So only 3 of you answered, and that too only 1 correct. That's not difficult. So we discussed a concept that normal to a surface. Normal to a surface. So sphere is a surface, definitely surface of the sphere. Now we need to find the normal to the surface. So just look at this, what we discussed earlier. I did a review also. And when I was discussing the review, I said this is very, very important. The concept of gradient. I said grad f is normal to the surface, the level surface f of x comma y comma z equal to c. All right. This part we discussed. Now let us go back to the problem now. So this f of x comma y comma z equal to c, the equation of the sphere is like the equation of the circle. X square plus y square plus z square is equal to 1. It is sphere of unit radius. So unit radius is 1. Just like x square plus y square is equal to 1 is equation of the circle with center at origin and radius 1. Similarly, equation of the sphere is x square plus y square plus z square is equal to 1. And 1 square represents the 1 represents the radius. So x square plus y square plus z square equal to a square represents a sphere of radius a. So here it is 1. Now unit normal at any point x. Now this x, y and z already are such that they are they like the directional cosines. Okay, x, y, z are directional cosines because L square plus M square plus N square is equal to 1 already. So grad f will directly give you the normal. So I cap times dou f. So this is f. So dou f by dou x plus j cap times dou f by dou y plus k cap times dou f by dou z. So what we get? I cap times we get 2i plus j cap times 2 I cap times 2x, j cap times 2y plus k cap times 2z. So this is the gradient. Now the unit vector if we want to find the modulus will be 2 times root of x square plus y square plus z square 2 times 1. Therefore the unit normal, so unit normal is grad f by modulus of grad f. You will get xi plus yj plus zk. So therefore the unit normal, the coordinates are given, it is a vector coordinates. So this is x comma y comma z. This is the correct answer. All right. Is that clear?
Yes, sir.
Okay. So let's move on. So the next question. This again, all are previous year's GATE questions. So you can see how important this section is. So now this is a temperature. So T of x comma y comma z is temperature, x square plus y square plus 2z square, temperature at any location. Now find the magnitude of the temperature gradient at 1 comma 1 comma 1. This is an easy question. In 2.5 minutes, you should be able to do it. Less than 1 minute, in fact. But for practice sake, I'm just giving. Yeah. Students have started answering already. 2 of you have already answered. Good. I see many correct answers. So you're getting a practice of it. Okay. So let's begin. So gradient of T, I dou T by dou X plus J dou T by dou Y plus K dou T by dou Z. So this is 2x times I plus 2y times j plus 4z times k. Now at the gradient of the temperature at P1, 1, 1 will be 2i plus 2j plus 4k. Now the magnitude of this will be under root of 2 square plus 2 square plus 4 square. So 16 plus 4, 20 plus 4, 24 under root 24. That is 4 into 6. That is 2 root 6. 2 root 6 is the correct answer. Simple. I just had to find the gradient. At a point, what is the magnitude of the gradient? It is not asked for, normal, and it is not asked for directional derivative. They just said magnitude of the temperature gradient. It didn't ask in a particular direction also. So, all right, next question. So, the next question. So again, this is a question on spherical surface. 1 comma 1 comma x square plus y square plus z square is 1. Please start answering. I'll give you another 2.5 minutes. All right. Again, it's a simple one. So f of x comma y comma z is equal to c. It is in this form: x square plus y square plus z square is equal to 1. So unit normal. So normal to the surface is grad f. Grad f is normal to the surface. So it is partial derivative with respect to x I, partial derivative with respect to y j, plus partial derivative with respect to zk. So again 2xi plus 2yj plus 2zk. Now it is said at this point, the gradient, the normal vector at this point. At this point, whatever the given point, I'll call this as P. So at P. So substitute unit outward normal vector. So we get 2 by root 2 times I cap plus 2 upon root 2 j cap plus 2 into 0 k cap. So we get root 2 I plus root 2 j. Now the normal vector, the unit normal, unit outward normal. For this, divide by the magnitude. Magnitude will be 2. This will be the unit outward normal. I plus j upon root 2. I plus j upon root 2. So that is I upon root 2 plus j upon root 2. This is the correct answer. Look at the next question. Again, a simple problem, directional derivative. This, with so much practice, I would say that you should do it within 2 minutes. Okay. So directional derivative is del grad f dot a cap. Now grad f, I will directly write it is 2x times I plus 4y times j plus 1 times k. Partial derivative with respect to x I, partial derivative with respect to y j, partial derivative with respect to z k. Dot a cap is 3I minus 4j upon 5. So this is 2 into 3, 6x upon 5 minus 16y upon 5 plus 0. Now this at which point p? 1 comma 1 comma 2. So 6 into 1 upon 5 minus 16 into 1 upon 5 plus 0. So we get minus 10 upon 5, which is minus 2, which is minus 2. So this is the answer. Okay. So next question. Next question is on divergence. So far it was all gradient. Next question is on divergence. This is divergence of a vector field. So far it was gradients of scalar fields. So hoping that you will do it in 2 minutes. Good, many questions, many answers, many correct answers. Another 15 seconds, I will wait. Okay, so divergence is del dot vector. So I dou by dou x plus j dou by dou y plus k dou by dou z of 5xyi plus 2y square j plus 3yz square k. So I dot I, you will get I dot I is 1 and dou by dou x of 5xy plus dou by dou y of 2y square. Okay, so it is usually a1 b1 plus a2 b2 plus a3 b3, but it is not just a product, it's an operation, the derivative, partial derivative operation on this. So this is 5y plus 4y plus 6yz, keeping y as constant, differentiating z square, that will give us 2z, so 6yz. Now we need to find this at 1 comma 1 comma 1. So 5 times 1 plus 4 times 1 plus 6 times 1 into 1. So it is 5 plus 4, 9 plus 6, 15. This is the correct option. Okay, so divergence of a vector field. So next, another question. So please do this. This is a simple one. You should do this within a minute. Got many correct answers. So this is the vector f bar, let's say. So you get dou by dou x of x minus y plus dou by dou y of y minus x plus dou by dou z of x plus y plus z. So divergence is a scalar value actually. So dou by dou x of this x component is 1, I component. Dou by dou y of j component is 1. Dou by dou z of this is 1. So we get 3 as the correct answer. Three is the correct answer. This is a question. I'll give you 3 full minutes for this to solve. Okay, I'll do this problem. It is little involved. So direction of vector A is radially outward, and this magnitude is this. So this vector A will be modulus of A times xi plus yj plus zk. Radially outward vector means this divided by its modulus. This is modulus. This is a unit vector. So we get this as modulus of A is k times Rn, r power n, and denominator is r. So A is this k times r power n minus 1. Of course, r is not a constant. R is a function of x, y, z. So this is the trick. Now we want to find when is the divergence 0. That means k is a constant, comes out dou by dou x of r power n minus 1 times x plus dou by dou y of r power n minus 1 times y plus dou by dou z r power n minus 1 times z should be equal to 0. If this is equal to 0, then we have to find that value of n. Now when we differentiate, see, let us put dou by dou x r power n minus 1 times x, which is r power n minus 1 into partial derivative of x plus x into n minus 1 times r power n minus 2. Okay, r power n minus 2 into derivative of r, or so derivative, partial derivative with respect to x. So this is dr by d dou r by dou x r power n minus 1 plus x into n minus 1 into r power n minus 2. Dou r by dou x is x upon r. 2x upon root of x square plus y square plus z square. So we have r power n minus 1 plus x square into n minus 1 into r power n minus 3. So similarly, we'll have to do for, so therefore del dot A will give us k times this r power n minus 1 will be common to all. So 3 r power n minus 1 plus we get x square plus y square plus z square into n minus 1 times r to the power n minus 3. Now this, I am adding the other two. In the other two, we have done partial derivative with respect to x. So we get this. For the other two, we'll get y square and z square. So when we do this, this is r square. So we get 3 r to the power n minus 1 This is r square. So this is n minus 1 times r to the power n minus 1. So what we get is k into 3 plus n minus 1, that is n plus 2 times r power n minus 1. Del dot A is this. For divergence to be 0, r will not be 0. N can be 0. For divergence, so we have n plus 2 is equal to 0, which implies n is equal to minus 2. This is the answer. All right. This was a little involved. Not that concept was difficult. It was just that calculations was involved. That's all. All right. I'll stop here for today. Another 4 questions are there. We'll continue in say tomorrow's class, and I will do Laplacian, and then we'll move to line integrals in the tomorrow's class. Okay. I'll stop here for today.
Sir, can you once explain how in the 11th question you did dr by dx to x by r again?
Which one?
Yeah, you converted partial derivative of dr by dx to r
Yeah.
by x.
R is root of x square plus y square plus z square, correct? Dou r by dou x is 1 upon 2 root x square plus y square plus z square times 2x. So this is x upon root of x square plus y square plus z square. So this is x upon r. Got it?
Yes, thank you. Sir.
So similarly, dou r by dou y will be y upon r. Dou r by dou z will be z upon r.
Yes, sir.
Because pattern is the same.
Yes, thank you. Sir.
All right.